Welcome everybody. So in this video what we're going to do is to play around with the scanf function that we discussed in the previous lecture, and we're basically going to take in or input two integers, add them up, and then print the result, and then maybe make some changes and see what happens when we do. So I've written out the program that we discussed in the previous lecture. You can see we have declared first of all integer 1. We first define that to be an int data type, and we define integer 2. Then we prompt the user to enter the first integer. Then we use scanf to input this integer 1, and then we repeat the same thing for integer 2, and then finally we add them up and store the result in another integer variable called sum, and that's pretty much it. So let's run this and see what happens. Quick trick, if you do not want to go all the way up here and click on this button to run your program, what you can also do is just press the F5 key on your keyboard, and it should make the program run. Now this is something that you were not expecting, that we get some build errors. So let's see what the problem is. Actually this is something which was expected, but I put this in there on purpose. So you see this scanf, this function or variable may be unsafe. Consider using scanf underscore s instead. So what basically has happened is, since the time that C language originally started out, there's been a lot of water under the bridge. I mean, it's been more than 40 years, and you know, the conventional or the old scanf function had some problems which could cause some serious errors related to your in your computers. And so what Microsoft has done is that in their Visual Studio they have introduced a much better version of scanf, which they refer to as scanf underscore s, and I think that this is probably a bit more secure than the conventional scanf function. So let's go ahead and do that, and so once we do that, this program should run. So let's see if it does. Yep, it does. So let's enter two numbers. Let's enter maybe 13 and then 14, and then the answer is 27. So the program starts to work. So right, that's great. So let's now try out a few more things. Let's say that we want to maybe change this statement, make it a bit more friendly. So, you know, maybe write this as the result of operation is, you know, this. So this could be another way of writing this. It's a little bit more user friendly. Another thing that you may want to do is to show the user what are the values of the two numbers that are being added. So what you could do is maybe you know, maybe you want to print both integer 1 and integer 2 in this final statement as well. So there's a way that you could actually accomplish this, and you can accomplish this by putting a placeholder or percentage %d here, which basically will indicate one integer, and then you can write result of this plus another placeholder for another variable, and instead of operation you could write is equal to this. Now over here, because now you want three variables to be printed, one way to actually modify this so you can print both integer 1 and integer 2 is to put both integers here, and then see what happens. So again, let's look at this again. So what we've done is, what we really want is to have this value of the final statement show us both the numbers that are being added up, and then show them with the result. So let's see if this actually allows us to do that. So let's take this program, run it again, maybe add two numbers, 45 and then 7, and it's telling you result of 45 plus 7 is equal to 52. And what basically this has done is in the final statement, this percentage D is replaced by integer 1, the second percentage D is replaced by integer 2, and then the final one after the equal to basically gets replaced by the value of sum. You could have different variables, different values for integers, and the values would change accordingly. So let's run this again. Maybe if this time I enter two different numbers, 77 and maybe 91, and it will tell you, okay, result of 77 plus 91 is 168. Now you don't necessarily have to limit yourself to just summation. In fact, so let's replace this sum variable with maybe result. So let's call this result, and call this result as well. And let's say this time we maybe want to subtract the first number from the second one, sorry, the second number from the first one, and then let's see what happens. So let's say 50, the second number might be 23, and the answer is 27. Okay, one thing I forgot to do was here I need to change this to minus, so it really reflects what I'm doing. So I do that again, 6 and then maybe 9, and it shows you the result is -3. Okay. You could also try maybe multiplication. So in multiplication, recall that multiplication in the language has to be represented by an asterisk, and let's repeat this again quickly and see what happens. So let's say 4 times 6, the result is 4 times 6 is 24. And you don't have to write an asterisk here, because this is something which is going to be read by a human. So if you don't want to be, you don't really don't have to see an asterisk, you can just put this, make it look more natural, so the user actually sees something that they're more familiar with. For humans who are not programmers, actually normal human beings, you can replace the asterisk at least in the text statement with an X, because it generally makes more sense. So 3 times 5, and the answer is 15. So you could do it this way as well. And then finally, division is more interesting. So let's say if we want to do division, so we can write this as /, and then maybe see what that does. So let's say divide 100 by 2, and the answer is 50. So it shows you that. Okay, now one more thing is, let's say we come up with an answer which is which may not be an integer value, which might be actually be a decimal value. So let's see what happens in that case. So one more experiment that we can do is maybe divide 100 by 3, Uh, and in this case, the answer that we would expect, the actual answer should be 33.333, but because the result is also declared as an integer variable, what tends to happen is that the value after the decimal is discarded, because the computer stores the result in an integer variable, and integer variables do not have decimal values, so the decimal values will be discarded. Furthermore, if you're dividing two integers, the result is also going to be an integer. So even if you're, I will have to check this in a bit more detail, but I'm pretty sure that if you divide two integers by integers, the result is still going to be an integer, even though you may be storing them in maybe in a non-integer or a decimal variable. So, but I don't remember this 100%, so let me check this and maybe get back to you on future lectures. In fact, let's just quickly do an experiment, even though this is something that you may not have looked at before. So let's just quickly do that experiment. Convert this into float. Float are basically is a data type which is used to store decimal values, so it can store decimal values. So let's see if it actually gives me the correct result, or if it does not give me the correct result. So this is something, even though I don't remember, I can double check it. So let me just quickly double check it and see if I remember my freshman C programming correctly. So let's enter 100, divide by 3. Actually, that's odd. It actually gives me 0, which is something that I was not expecting at all. Alright, so yeah, well, why did that happen? Actually, if I look at the code more closely, what you actually need to do also is, if you're using a float data type, then you also need to change this part here. And the problem that was, the problem with the previous case was that even though I had declared result as something which was not integer, I had not changed its data type. So now when I change the data type, and if I run the program again, so hopefully this should work. And so now you can see that the value that you get is in decimal, but again, the problem is that you don't see that 33.333 values are actually 0, and the reason is because the first two integers are basically defined as the first two variables that are being divided are, because they're defined originally as integer variables, so the result is still going to be an integer value. So C language does take that result and it does convert it into a decimal number, but before it can do that, the decimal numbers have already been discarded, so it doesn't really matter. So you still do not get the right answer, and so it's good to know that I still remember my freshman C language reasonably well. Okay, a couple more things that we can do. So let's not talk about floats for now. We'll come back to these. Let's go back here and go back to where we were. So and so finally the program is in the shape that we wanted it to be. So let's just say 100 divided by 4, and you get a 25. One more thing that we can do, of course, is, let's say we want to do like a mod. So if we want to do a mod, we have to use this, and which is basically the percentage sign. Let's use that here as well, see if it works. So 100 divided by 3, and so the remainder is actually 3. Now notice that in the result you get some sort of a problem. You're not really expecting this, even though the answer is correct. So what happened here was, obviously percentage actually has a special meaning over here, so we should be using an escape sequence, but even if we used an escape sequence, which was basically, or escape character, which was basically the backslash, we still wouldn't get the right answer. Let's quickly verify this. We still wouldn't get the answer in the right format. So and the reason for this is that, again, for the percentage sign, if you really want to print a percentage sign, you have to print it this way. Now this is unfortunate, but that's the way it is, so you have to just remember it. And so let's do this again, maybe 4, and the modulus basically, now it gives you the right answer, so the remainder is basically 2 if you divide 10 by 4. One more thing that I probably want to cover is that, in this part, what you can do is, you don't really have to write this statement. Another way of writing this is, you could actually get rid of this, and even these 2 statements, as we mentioned in the lecture, you don't have to write them on 2 different lines. You can actually write them on the same line, so you can write them like this. And over here in the statement, you don't have to actually declare a separate variable to store the result. You can actually just do the operation at this particular location within the printf statement. So what you can do is just take integer 1 and divide that by integer 2 here, and it would still work. So let's just go ahead and do that for a second. 10 divided by 2, actually we also need to change this here, because the operation that we're doing now is not mod, it's division. And that's that. So that's it. Thank you so much. I'll see you in the next lecture.